UC Berkeley will manage $300 million NASA mission to map the UV universe. The Andromeda Galaxy, M31, looks much different in optical, left, versus ultraviolet wavelengths. UVEX will conduct an all-sky survey to find UV sources, searching in particular for hot binary stars in low-mass galaxies surrounding the Milky Way and for the signatures of exploding stars. Optical, atom block/NOO/aura/NSF, UV, Galex/JPL/NASA. March 25, 2024. Share link. An orbiting space telescope approved by NASA last month and scheduled for launch in 2030 will conduct the first all-sky survey of ultraviolet, UV, sources in the cosmos, providing valuable information on how galaxies and stars evolve, both today and in the distant past. The $300 million satellite mission, called UVX, Ultraviolet Explorer, will be managed by the Space Sciences Laboratory, SSL, at the University of California, Berkeley. The mission's principal investigator is Fiona Harrison, a UC Berkeley PhD recipient who is a professor of physics at the California Institute of Technology in Pasadena, California. The telescope's all-sky UV survey will complement ongoing or planned surveys by other missions over the next decade, including the optical and infrared Euclid mission led by the European Space Agency with NASA contributions, and NASA's Nancy Grace Roman Space Telescope, an infrared telescope set to launch by May 2027. Together, these missions will help create a modern, multi-wavelength map of our universe. When UVX launches, for the first time we'll have the entire sky covered from the UV all the way through the infrared, said Daniel Wise, one of the science team leaders for the UVX mission and a UC Berkeley Associate Professor of Astronomy. Having ultraviolet coverage of the entire sky, which has never really been done before, is groundbreaking. UV emissions come from hot objects, but these wavelengths are blocked by Earth's atmosphere and must be studied from space. The survey will focus on hot, massive blue stars, many of which are thought to be members of binary star systems, as well as exploding stars. In binary star systems, the most massive of the stellar pair often strips material from its companion, which exposes its hot UV-emitting core. UVEX will map the distribution of these stripped stars and galaxies around the Milky Way. UC Berkeley astronomer Daniel Wise joins Caltech's Fiona Harrison and other leaders of the UVX team in explaining the importance of the planned ultraviolet telescope to our understanding of galaxies, stars, and stellar explosions. Video courtesy of Caltech. The telescope also will carry a UV spectrograph, jointly built by UC Berkeley and Caltech, to record detail about the UV wavelengths emitted by massive stars and during stellar explosions. These observations will provide new details about how stars and galaxies form and how they die. One of the things we're going to produce is a chart of the whole pathway from the genesis of these binary stars all the way to what happens when they explode and interact with whatever materials around them that they've lost over time, he said. UVEX will just completely change the field. UVEX will also be able to quickly point toward newly discovered sources of UV light in the universe. This will enable it to capture the light that follows bursts of gravitational waves caused by merging neutron stars in binary systems, events that are regularly recorded by 3 large collaborations around the globe, including the Laser Interferometer Gravitational Wave Observatory, LIGO. A lot of transient events are best seen in the ultraviolet, said Bill Craig, UVEX project manager. Having a wide field of view to follow gravitational wave events is a really strong reason for selecting this mission now, so that as LIGO goes through its next campaigns, UVEX will be up there to zero in once they see a merger. We then can zip over and see the aftermath of that. Low-mass galaxies today and in the early universe. Wise is particularly interested in low-mass galaxies, those that are about 1/10 the size of the Milky Way. The most famous of these are the Large and Small Magellanic Clouds, satellites of the Milky Way that are 1/10 and 1/100th the mass of the Milky Way, respectively, but there should be millions of smaller galaxies within our galactic neighborhood. Only about 50,000 have so far been seen, and few have been studied spectroscopically at UV wavelengths.